Yeah, welcome to section 5.4, which is on systems of nonlinear equations. If you watched 5.1, you're not going to see anything different. The only thing is that instead of dealing with just lines like we do in 5.1, now we're going to have things like a line in a circle, or two circles, or parabola in a circle, or two parabolas, or whatever. I'm going to end up doing the same types of things. I'm still going to go through substitution, I'm going to go through elimination, go through graphing. Graphing method, they're all the same. So just so that you guys know that if you're looking for the steps of the process, watch 5.1. That'll give you the same type of the same steps that I'm going to do as far as solving. But if I give you something like this and ask you how are you going to get the answer, well, if you use substitution, for instance, I'm going to solve for y. So if I add y to this side and subtract 10 to that side, I have 3x minus 10 equals y. This is going to be replacing this. So I'm using the substitution method. This method, just to let you guys know, is a little bit more complex than your substitution method that we had in section 1 because we've got a lot of squaring going on. When you square a binomial like that, you need to, I like to tell my students to write it out twice and FOIL it. There is a kind of a fast little rule if you want to use it, but realistically I've found so many students mess up one sign or they forget a piece, where I tell them it's just easier if you just write it out twice and FOIL it, you'd get it right then every time. So if I FOIL that out, I get 9x squared minus 60x plus 100 equals 100. So if I combine like terms, I have 10x squared minus 60x, and if I bring over this 100 from here and setting it equal to 0, then I have this. This goes right back to quadratics, which is what we solved way back in chapter 1, like section 4, I think, where now we're going to use either the quadratic formula, completing the square, or factoring. I can factor. I'm going to take a 10x out of both of them, which gives me x minus 6. And if I set each group equal to 0, 10x equals 0 or x equals 0, x minus 6 equals 0 or x equals 6. Now, those are the two x's. Then what you do is you plug those back in individually and see what y would match with it. So 3 times 0 minus 10 equals y. So y would equal negative 10 in this situation. So this ordered pair of 0 and negative 10 is one where it would cross. Then if I do 3 times 6 minus 10 equals y. 3 times 6 is 18 minus 10 is y, so y equals 8. So the other ordered pair that would also work is 6, 8. Now on the other ones, if you notice when I did them, I just kind of boxed in my x's and my y's because there was only one ordered pair where they were going to cross. This has got multiple ordered pairs or multiple options, so I would suggest that you write them out individually. So this is an answer and this is an answer. So just so that you guys know, you're going to have a lot of times two answers for this, maybe only one answer if it only hits at one time, or no answers if they don't hit. So just so you know, the process that I went through there with the substitution method, it's the same method that we had in section 1. The method that would not work in this case would be elimination. The reason why elimination won't work is because the variables don't match. And what I mean by variables in this case is these are squared where these are not. You have to be where everything matches, where the exponents would have to match on the letters in order for you to use elimination. If they're different exponents, you can't do elimination. That's the only downfall. Everything else is fair game though. Substitution and graphing are all the same. Graphing, when you're setting it equal to y, make sure that if you're having to square root to get rid of the y, that you put in both the plus and the minus. So for instance, if you were doing something like, if you had x squared plus y squared equals 12 as one of your graphs, when you subtract x squared over, and when you square root it, remember you get y equals plus or minus the square root of 12 minus x squared. Well, if you recall from a long time ago in chapter 1, this is a circle. If you just put the square root of 12 minus x squared into the graphing calculator, you're going to get something like this. That's not a circle. So this has to be in y1. In y2, you have to put the negative of the square root of 12 minus x squared, and that will give you the bottom half of your circle. Okay? So just so that you are aware of it, that's how you're going to have to draw a circle. And then if you have another thing coming in there and hitting it, let's say that I just kind of drew a line in here like this. It hits it once here, and it hits it once there. And if you're using the graphing method where you're putting it into the graphing calculator, when you're going second intersect, what it's going to ask you to do is, I can't spell apparently, is it's going to ask you first curve, second curve. Well, first curve is the top half of the circle, the second curve is the second half of the circle, and the third curve is the line. So you want to go first and third, and you want to go second and third. So in order to do this, when they ask you, they're going to say first curve. If you're on the top half of the circle, hit yes. Then it'll ask you second curve, and it'll put it in the bottom half of the circle. Then use your down arrow and maneuver to the line, and then I'll get it for you. So as far as section 5.4 goes, there isn't anything new other than what we did in 5.1. So this really doesn't have a whole lot to do in this particular section. So good luck.